Hi, students. Hello, everybody. Yes. Hi, Vijaya. Hi, Sanika. Hello. So let's just wait for a few minutes and then start. Okay. So today we will be discussing some questions from moving charges and magnetism. So I got a request from some students asking for concepts. They want me to explain concepts. So if you want me to explain concepts, you can just let me know in the comments. Okay. And I hope all of your preparations are going well. Can you all let me know in the chat how your preparations are going? How many of you are scared for KCET? Hi, Nikita. Yes, Pragnya, I've tried. I think my pen will work well. I did some trials and I hope we can do a good class today. I'm very sorry, last class my pen was not working. I couldn't write anything on the board. Very sorry for that. Princess wants theory. Okay. Yes, we have. Okay, so let's start. Can you all send this link to your friends so they can also start the class? For those who've not, those of you, those who didn't know about the class, can you send it to all of your friends so we can quickly start? So let's start some questions. So today, as you all saw on the thumbnail, we will be solving some questions from moving charges and magnetism. So all the questions that are going to be done today are from previous year papers. And some are easy, some are difficult, some are medium questions. We will solve all wide varieties of questions, and hopefully my pen will work well, so we will do a good class today. So I want your support for that as well. Okay? So let's start. Question 1. Yes, Rutu. Yes, this chapter was your nightmare. So I'll try to make it something that you like. Larika, I'll try to explain theory, but we have time constraints. So for whatever questions I have, I'll try to explain the theory behind it. Okay, so let's start. So first question. A moving electron produces. The options are electric field only, both electric and magnetic field, only magnetic field, neither electric nor magnetic field. So in this chapter, the first concept that you need to know is based on this question. That's why I've put this question. So an electron that is moving will obviously have an electric field. It's an electron. An electron will obviously have an electric field around it. But a moving electron will always have a magnetic field around it. So if you have a wire, okay, and you have current passing through the wire, this wire will always have a magnetic field around it. And the direction of magnetic field is given by the right hand thumb rule. So your thumb gives you the direction of current and the fingers curl to give you the direction of magnetic field. Okay, so obviously what would the answer be? It would have both electric and magnetic field because it's a moving electron. So in this chapter, the first concept that you need to know is a current carrying wire which has electrons that are moving will always have a magnetic field. Okay. Yes. So all of you have electric potential. I didn't miss. I will do that. So we will do chapter by chapter. I'm not going in the exact order. I will do high weighted chapters first and then we will move on to other chapters. So did you all get the answer as B? If you all got the answer as B, can you all put a thumbs up and can we move on? Can I have some thumbs ups? So let's go to the next question. Okay. Next question. A coil having 9 turns carrying a current produces a magnetic field B1. So I have a coil This coil has 9 turns like this. 9 turns. Okay. So can you see it because of my head? Okay. So this coil has 9 turns and it has a magnetic field V1. Now I take this coil, I remove the extra turns. Now I have only 3 turns. Okay. So now I have made it into 3 turns. So 3 turns. So now my magnetic field is V2. Another thing that is given to us in the question is both carry the same current. So both the 9 turns coil and the 3 turns coil both carry the same current. Okay. Now, what equation will we use here? Let's quickly solve it. I hope you've understood the concept. You have a coil which has 9 turns and that coil has a magnetic field B1 and then I remove the extra turns. Now I have only 3 turns. Now the magnetic field has become B2. So I have to find out the relationship between B1 and B2. Basically, I have to find out B2 according to the question. So let's look at the solution. Yes, let's look at the solution. So first thing, number of turns n is equal to 9. That is the number of turns. Now, let's look at the magnetic field. So magnetic field B1 is basically mu 0 n number of turns into the current divided by 2R. So magnetic field because of a current carrying wire is mu 0 I by 2 bar. I by 2R, sorry, mu 0 I by 2R. Because there are n turns, I will put it as n into mu 0 I by 2R. If there's only one turn, it's just mu 0 I by 2R. So this, I substitute the value of n, it becomes 9 mu 0 I by 2R. So this is the magnetic field because of 9 coils, magnetic field B1. Now let's find out magnetic field B2. Magnetic field B2 is because of 3 coils. So this would obviously become 3 mu 0 I by 2R. Okay. But let's write it as 3 mu 0 I by 2. The radius will be R dash. Now to equate both these, you need to have some common terms. So what I will do is, I will find out the relation between R dash, which is the new radius, and R, which is the old radius. So let's do that. Okay. So if let the radius of turns be R dash. Yeah. If the radius of turns be R dash, then 9 into 9 is the number of turns. And the radius, the circumference of one turn will be 2 pi r. If r is the radius, the circumference is going to be 2 pi r. 2 pi r into how many turns are there? 9 turns. So 9 into 2 pi r. This has to be the same as 3 turns with 2 pi r dash. Because in the question, it does not tell us that the radius or anything is changing. Okay. It just says the number of turns are reduced. But the total, which is the total area or the total circumference should be the same. So 9 into 2 pi r should be equal to 3 into 2 pi r dash. 2 pi r and 2 pi r dash is the circumference of the loops. So from this, obviously 2 pi cancels. So 9r is equal to 6r dash. So r is equal to, what is 6 by, I'll cancel 9 and 6. So it becomes 3r is equal to r dash. It's not, yeah. So I'll look a different color. So 2 pi and 2 pi cancels. So this is not 6, it would be 3 only because I cancelled the 2 pi and the 2 pi. So this would be 3. Is this much clear? Now I have 3R is equal to R dash. Now I will substitute that here. So this becomes 3 nu naught I divided by 2 into 3R, which is mu 0 I divided by 2R. 3 and 3 cancels. Yes, Sanika, 2 pi cancels. Now I have B1 and B2. The question is to find out the relationship between B1 and B2. So let's do that. So I will draw a line here. So let's divide B2 by B1. I think I'm on the board. Can you see because of my head? I have to just move away. Yeah. B2 by B1 would be, how much is B2? Mu 0 I divided by 2R. The whole divided by, what was my B1? 9 mu 0 I by 2R. Okay. So mu 0 I cancels. 2R and 2R cancels. And what happens? 9 comes up. So this is basically 1 by 9. So I get B2 to be equal to B2 by B1 to be equal to 1 by 9. So from this, what is B2? B2 equals B1 by 9. Which option is that? B2 equals B1 by 9. Option A. So the answer is option A. How many of you got option A? Can you all let me know in the chat? So if you got option A, can you put a fire? All those who got option A, please put a fire. So here in this question, what we have done, we had a coil which had 9 turns, okay, and then we reduced it to 3 turns. So the total circumference is not going to change. That is why I could take 9 into 2 pi r is equal to 3 into 2 pi r dash. And then I substituted that in the magnetic fields of B1 and B2 and then found out the ratio. Okay, quickly, can you all put some fire emojis if you've understood this question so that we can move on? Quickly. Yes, Vaishali and Sav, you have understood. Others, not clear. Quickly, so we can move on to the next question. Okay, the next question. The magnetic field at the center of a circular coil. Okay, so we have a circular coil. The circular coil has a radius r and it carries a current I. Okay, so we have a circular coil. This circular coil has a radius r and it has a current I. This is equal to 64 times the magnetic field. Okay, and it's at a distance x on its axis from the center of the coil. Okay, let's do this. So we know that the magnetic field on a a current carrying coil is basically mu naught I divided by 2r. Okay, it's mu naught I divided by 2r. Now we have to find out. Okay, so this is the magnetic field at the center of a coil. Mu naught I by 2r. Now I need to find out the magnetic field at a distance x from the coil. So this is B center. Now Bx would be, so you might have learned the formula for the magnetic field at a point X outside the coil. It is mu naught IR square, the whole divided by 2 times R square plus X square, the whole raised to 3 by 2. So these are two standard formulas. If you have an equation sheet, you can actually write this down. Okay. So the magnetic field at the center of a coil is mu I by 2R, and the magnetic field at a point X from the center is mu IR square divided by 2R square plus X square raised to 3 by 2. So here R is the radius of the coil and X is the distance. This is X. Okay. Now in the question, it tells us that, what does it tell us? It tells us that the magnetic field at X, at the point X, is 64 times the magnetic field at the center. So that means B center is equal to 64 times the magnetic field at point X. So this is one relationship we have. Now let's use a formula. What is B center? Mu naught I divided by 2R. This is equal to 64 times the magnetic field at point X. How much is that? Mu naught IR square divided by 2R square plus X square raised to 3 by 2. Now let's cancel off all the common terms. Let's do that with a different color. Let's cancel off with green. Okay. So nu naught I is common. Nu naught I is common. 2R. Let's see. If we solve it even further, we can cancel. So this 2 and this 2 I will cancel. Okay. Now let's write what remains. 1 by R is equal to 64 times R square divided by R square plus X square, the whole raised to 3 by 2. Okay. Now, what will I do next? I have to obviously simplify this. Let's do the simplification. So for that, before simplification, I will rearrange the terms. So I will take this to this side and this to this side. So R square plus X square, the whole raised to 3 by 2 is equal to 64 R cube. I will draw a line and write the others on the other side. Now I'm going to take cube root on both the sides. Okay. I just want to eliminate 3 by 2. So to eliminate 3 by 2, I will take the cube root. So R square plus X square will now be equal to 64R, the whole raised to 2 by 3. So to eliminate 3 by 2, I put 2 by 3 here. Now if you do 64 raised to 2 by 3, you actually have to find out, how do you do that? You have to find out, so 4 cube is, so the power of, if you look at the power of 4, that's how you get 64. So if you do this, you would actually get 64 raised to 2 by 3 would be 16, which is basically 4 cube is going to give you 60. 4 cube is going to give you 64. Okay. So you take 4 and then there is a square also. So 4 square is 16. That's how you do 60. So let's do that, substitute that. So R square plus X square is equal to 16 R. Okay, we had a cube here. Did we miss that? Yeah, there was a cube here. Okay, yeah. 16 R cube 2 by 3. So the cube and cube cancels. This becomes 16 R square. So R square plus X square is equal to 16 R square. So X square is equal to 15 R square. X is equal to square root of 15 R square, which is square root of 15 into R. So let's see which option is X equals square root of 15 into R. It's option D, right? Did you all get option D? So the correct answer is option D. So if you all got option D, can you all give me some response in the chat? Yes, Vaishali, it's R root square root 15. So I'm explaining every step because I don't know to what audience I'm talking to. I could be talking to a wide range of students. Some of you might understand it very fast. Good for you. Some of you might take time. Some of you might need all the steps. So let's make this a neutral class where everybody understands. So that is why I'm explaining all the steps. Okay. So those of you who feel this is, if you feel this is slow, you can watch the recording at 1.5 or 2x speed. So since this is a class of a wide range of students, let's make it fair to everybody. So the smart ones, good job if you've got the answer already. So if you've enjoyed till now, if you're getting the answers, can you all go like the video and come back quickly? Yes, I sure it's option D. Good, it's option D. Okay, let's look at the next question. Question 4. So the torque acting on a magnetic dipole placed in a uniform magnetic field is 0. When the angle between the dipole axis and the what is the angle between? No, you have to find out at what angle you can happen. What angle this can happen. Okay. So this is a very simple formula. Torque is equal to mb sine theta. Okay. Now for the torque on a magnetic dipole placed in a uniform magnetic field, for it to be 0, this whole thing has to be 0. So mb sine theta should be 0. That means m and b cannot be 0 because the magnetic field and the moment will not be 0. So the only thing that can be 0 is sine theta. So if sine theta is equal to 0, theta would be equal to sine inverse of 0. So theta could either be 0 degree or 180 degree. That means the torque is 0 when the dipole is two poles, the north and the south. When the dipole is aligned, parallel or anti-parallel to the magnetic field. So if the magnetic field is in this direction, the torque can be in this direction or the opposite. So parallel or anti-parallel. Okay. So the answer is 0. Option A, 0. Yes, Pragnya, Vaishali, yes, it's option A. Okay, that was a simple question. So let's move on to the next question. So you have two particles, a proton and an alpha particle. They are moving with the same velocity. So velocity is same. And they enter a uniform magnetic field. Uniform magnetic field. So magnetic field is also same. And their velocity is perpendicular to the magnetic field. Okay, you have to find the radius of their circular path. So in this question, the only hint that we have, the important hint that we have is it is going to take a circular path. So you have a proton and an alpha particle both taking circular paths. If something takes a circular path, what's its force? Centripetal force, mv square by r. anything that takes a circular path will have a centripetal force, which is mv square by r. Now, these are charged particles in a magnetic field. So, they will definitely have a force acting on them. So, that force is given by QVB. Okay, because there is a electric and a magnetic field, QVB. Now, for this particle to move in a uniform path, both of these forces have to be the same. So, mv square by r should be equal to QVB. Okay, let's cancel the common terms. So, r would be equal to mv divided by QB. R would be equal to mv divided by q into b. Now, in the question, it is given to us that velocity and magnetic field, v and v are the same. They are constants. They are not changing. So, I will try to put a proportionality here. How can you put a proportionality? To put a proportionality symbol, so anytime you want to put a proportionality, you have to have an equal to and a constant. So if you have an equal to and a constant, you can replace it with a proportionality. So let's do the same thing here. So since V and B are constants and you have an equal to, let's write R as proportional to M by Q. Okay. So that would be my first formula, that R is proportional to M by Q. Okay. Now, let's look at the parameters that are given to us. So first thing, it's a proton. So for the proton, let's say the mass is mp and then charge, which is qp, let's take it as E. Okay. Now, for an alpha particle, an alpha particle has two protons and two neutrons. An alpha particle is similar to a helium. A helium has two protons and two neutrons. So for an alpha particle, the mass of the proton and mass of the neutron is similar. So what will be the total mass of an alpha? Two protons, two neutrons. So 4 into the mass of a proton, because the mass of a proton and the neutron are the same. So 4 into mass of a proton. So 4 mp is going to be the mass of alpha. Now the charge of alpha would be how much? It would be two protons, two neutrons. These two neutrons have no charge, they're neutral. So the charge of two protons, the charge of one proton is E. So the charge of two protons would be 2E. So these are some of our parameters. The mass, okay, mass and charge. Now let's write down the ratio of the radii. So ratio of radii. So the ratio of the radius of the proton to the radius of the alpha. Let's do that. So it is m by q. So the radius of the proton would be mp by qp. And this is going to be divided by radius of the alpha, which is m alpha by q alpha. Now, mass of the proton is mp and charge of the proton is E, divided by mass of alpha is 4 times mp and the charge of alpha is 2 times E. So this would be mp by E into 2E by 4mp. Cancel all the common terms. So what remains? 2 divided by 4, which is 1 by 2. Now, Rp by R alpha is equal to 1 by 2. So that means the ratio is 1 is to 2. I hope this question is clear to all of you. So we are finding the ratio between the radius of a proton and the radius of an alpha. Alpha is similar to a helium. So that is why we are able to equate it. So if this question is clear to all of you, can you all give me some fire emojis in the chat? Yes, Surya, very good. Yes, it's 1 is to 2. Yes, Pragna, it's 1 is to 2. Yes, so the answer is option D. Very good. Okay, so if you can't see it because of my head, I will just move so you can take a screenshot. Okay, let's move on to the next question. Okay, let's move on to the next question. Okay. A proton moves with a velocity of 5 into 10 raised to 6. And an electron, sorry, it moves through a uniform field. E equals 4 into 10 raised to 6 to I know that number. And a uniform magnetic field of this much. So let me just make it a little small. So it's um, yeah, fine. Okay, now let's look at this question quickly. So first thing, I will write down all the parameters that are given to us. So first, the speed. So V is equal to 5 into 10 raised to 6 J cap. Then what is given? Electric field is given. Electric field is 4 into 10 raised to 6 times. What all are the parameters? 2 I cap plus 0.2 J cap plus 0 K cap. This is your electric field. Now let's look at the magnetic field. B is, all of these are vectors, okay? Yeah. B is 0.2 times I cap plus 0.2 J cap plus K cap. They all have their units and all. I'm not writing all that because we have to just do math. So let's write down everything that you need to do the math. Q is equal to 1.6 into 10 raised to minus 19 coulomb. Now let's look at the formula. What would the formula be? It would obviously be F is equal to Q times E plus V cross B. Now what is your Q? It's going to be 1.6 into 10 raised to minus 19 times. How much is E? 4 into 10 raised to 6 times 2I cap plus 0.2 J cap plus 0 K cap plus V cross B. What was my V? 5 into 10 raised to 6 J cap cross. How much would B be? 0.2 times I cap plus 0.2 J cap plus K cap. So this is the full, what do you say? The initial the conditions and I've just directly substituted. So this 10 raised to 6 is common in both. So I can take this outside. So this becomes 1.6 into 10 raised to minus 19 into 10 raised to 6 times. Let's multiply 4 inside. 4 twos are 8. 8 I cap plus 0.4 into 2. So this would be 0.8 j cap plus is 0 k cap, right? So it would be 0 k cap. No, I think there's a mistake. In the question, how much is it? It is 0.1. Yes. This is 0.1. Okay. Here also it's 0.1 k cap. So this is 4 twos are 8, 0.8 and then 0.4 k cap. Okay, 0.4 k cap plus 10 raised to 6 has gone outside. 5 into 0.2 I cap plus 0.2 j cap plus 0.2 k cap. Now let's do the cross term. Okay, so A cross B is equal to I j k. What is the first term? It's 5. 5 is j cap. So here. And then 0.2, 0.04 and 0.2. So small correction here. This is actually 0.2 into 0.2, which is 0.04. 04. It's a correction, so I'm putting it in yellow so you don't miss it. Now let's do this. This is basically I cap times. How do you do this? I think all of you know how to do this, but for those of you who don't know, you take I cap and then you ignore the row and column with I cap. You take the rest. Okay. So ignoring the row and the column that has I cap, what remains? This much. So with this much, this is your matrix. You multiply the diagonals and subtract it. So this would be 5 into 0.2, which is the first diagonal, minus the second diagonal, which is 0 into 0.04. This is I cap. Next is minus j cap. J cap is always minus. Minus j cap. So you ignore the row and the column that has j cap. So the row is basically j, 5 and 0.04. You ignore that. And the column is ijk. So what will your matrix be? 0, 0.2, 0, 0.2. So, okay, we'll write down the steps. 0 into 0.2 minus 0 into 0.2. Okay, plus k. Ignoring the row and column with k, you have the matrix 0, 5, 0.2, 0.05. So it's 0 into 0.5, sorry, 0 into 0.4 minus 5 into 0.2. So this is basically going to give you 5 into 0.2 is going to give you 0.1. So 0.1 I cap plus or minus plus k cap. I think you're not able to see. Okay, now let's see. Plus, okay, k cap into 1. Okay. So this is 1. Yeah, this is 1. Yeah. And this is 1 I cap minus 1 k cap. This is what you will get when you do A cross B. Now let's substitute that in our whole equation. Let's just put that here. So 1.6 into 10 raised to minus 19 into 10 raised to 6 times 8 I cap plus 0.8 j cap minus 0.4 K cap plus, how much is it? I cap minus K cap. Okay, and then how do you solve this? You just take the cap terms. Okay, you solve all the cap terms and you multiply it with this. So, what are the options? So, your answer would be 2.2 into 10 raised to minus 30. Okay, so it'll take a lot of time. So, I'm just going to give you this. So, when you do, you can do it quickly. So, it would be just solving the rest. Okay. Okay, how will you solve this? I can also show you this. 1.6 into 10 raised to minus 19 plus 6 times. This is going to be 8 square plus. 8 plus 8 is 9. So 9 square plus 0.8 square minus 0. So minus 1.4 square. So for ijk, it's always a square plus b square plus c square. So this would be ai cap plus bj cap plus c k cap. Okay. Now let's move on to the next question. So next question also I will have to enlarge it a little. Let me see. Let's look at the next question. Question 7. So a circular wire of radius r has n turns. Okay, radius r has n turns and carries a current I. The magnetic induction B at a point on the axis of the coil at a distance root 3 from its center. Okay, so it's circular. So you know what formula to use. We did a similar question. So a circular coil, let's do it. So the magnetic field for the center of a coil, and you know the magnetic field at a distance x from the center. Let's write down that formula first. So B is equal to mu 0 I r square. Since there are n turns, n divided by 2 into x square plus r square, the whole raised to 3 by 2. Okay, so B is equal to mu 0 I. This is the formula for magnetic field at a distance, how much? X from the center. Okay, now it's given to you that the distance is root 3r. So x is given to you. X, the distance between. So I hope you're understanding what I mean. So this is a point. So this distance is root 3r. So we have to find out what do we have to find out? The magnetic induction or the magnetic field at point B, which is at a distance root 3r. So x is equal to root 3r. Now what's the next step? Obviously substitute x in the main formula. Let's do that in yellow. Okay, so B is equal to mu 0 IRN, the whole divided by 2 times x square. Instead of x square, I can write it as root 3r square plus r square, the whole raised to 3 by 2, which is mu 0 I Rn the whole divided by 2 times root 3 square is 3. So 3r square plus r square raised to 3 by 2. How much is 3r square plus r square? Obviously 4r square. IRN divided by 2 times 4r square the whole raised to 3 by 2. So, see, all of these steps you don't have to write when you're solving KCET and you won't get the time to write all these steps. So, right now, why I'm writing all these steps is if there is at least one student who's confused in between, it's just for that one person. Okay? So, those of you who already know this, you can skip the steps straight away, write this formula. Our only goal is to get the final answer. Anyhow, you can get it. Okay? You don't have step marks. So, I am just writing steps because to give it's like a reference for anybody who misses anything to make sure you don't go wrong. So let's do this mu 0 IRN the whole divided by 2. 2 is outside. Inside I have 4 raised to 3 by 2. 4 raised to 3 by 2 times R cube. Okay, so this will be, what is this? Let's delete this. Okay. Now this will be 4r square into, let's put the numerator also, mu 0 IRN divided by 2 into 8r cube, which is mu 0 IRN divided by 16r cube. So one thing that I missed throughout was this r square. Okay, you have to put this. Yeah. And then you cancel these things. So what happens? Mu naught I n divided by 16r. Now what was our formula for the magnetic field of a loop? It is, where do I put it? Are you able to see it? I am not able to see it. Yeah, mu 0 ni by 16r. Is this clear to all of you? Can I know in the comments if it's clear to you? I know I'm a very messy writer, okay? Please bear with me. Okay, yeah. Now, let's move on to a theoretical question. Okay, solving all these long questions have made me also sleepy. So let's get some energy. Let's look at some theoretical questions. Yes, Vaishali, Pragna, yeah, Aishu, yes, okay. Yes, so let's move on to some theoretical questions. So, which of the following statements prove that Earth has a magnetic field? So, the first option is Earth is a planet rotating about the north-south axis. Earth is surrounded by ionosphere. A large quantity of iron is found in the Earth. The intensity of cosmic rays of charged particles is more at the poles than the equator. So here the answer is option D. Okay. So why is it option D? Because it says about charged particles. So cosmic rays come from space. Okay. And these cosmic rays have charges. So when these charges come in contact with a magnetic field, there is some repulsion force there. So that is why, depending on the magnetic field, the amount of cosmic rays will differ. So if the magnetic field intensity is very strong, the amount of cosmic rays will be different. When the magnetic field is smaller, the amount of cosmic rays would be even different there also. So that means if the amount of cosmic rays on Earth vary, that means there is a magnetic field. The magnetic field is what is the reason why the amount of cosmic rays vary, because cosmic rays are charged particles. Okay, let's move on to the next question. Okay, yes. See, I'm actually looking at a screen and teaching. Okay, so sometimes I just lose the thing that you are there. Okay, so please keep the chat awake so it always reminds me of this. Okay, mix with fun. Your guess is right, but when you solve it, it goes wrong. So the only tip that I can give you is solve lots of questions. Initially, take time, understand and solve. But later, you will pick up the speed. So you have to practice a lot. Only then you can clear well. Okay, let's move on to the next question. A copper rod AB of length L is rotated about end A with a constant angular velocity. Okay, Earth's magnetic field is deleted. All right. I will check that. If it's deleted, then you don't have to study. You can always verify with your NCERT textbook. So I've taken all past year question papers and I've made sure everything is in syllabus here, because for current electricity, I saw some questions were not in the syllabus. You don't have to learn anything that's not there in your syllabus. So when you learn, please stick to the syllabus and learn. A copper rod AB of length L is rotated about. So there is a rod. This rod has a length L, and then from point A it is rotated with an angular velocity W. You have to find out the electric field along A in the axis. So not perpendicular, the electric field is along the axis. So as I said, whenever you see questions that involve rotation, the first formula that you can use is F is equal to mv square by r. Now here the angular velocity is given, so instead of v square by r, you can take it as m omega square r. You might have learned this formula in your first PU. Omega is the angular speed. So when the rod rotates, the electrons in the rod also will rotate. That is going to produce an electric field. So there is an electric field. So if there is an electric field, the electric field has to definitely be at rest. It has a force. It will never stay there without giving any force. So the electric field has a force, and the force is basically E into E, the force of the electric field and the force of one charge, E into E. Now for something to move in a circular path, both of these forces have to be the same. So it becomes m omega square r is equal to E times E. Now what is E? E would be m omega square r divided by E. Now in the question, since they say the electric field is at a distance x, what will your r be? It will be x. So m omega square x by E. Where is that option? M omega square by x into E. Yes, it's option E. So all those who got option 9, question 9, if you got the option A, please give me some fire in the emoji. Can you all of you, if you're sleeping, can you all put some fire emojis? Yes, Joel, it's A. Is this clear? Can I have some response from all of you? Because only if you respond, I'll know that all of you are there. Okay, so a strong magnetic field is applied to a stationary electron. Yes, I should. Let the fire kick in. So next question. Yes. Okay, so I want you all to also, my PC battery is running low. It's connected. Okay, so there's one more thing you need to know. So if you might all have already known about this Meet Your Favorite Master Teacher that's happening. So if you want to go meet your favorite teachers, all your favorite teachers will be there. If you want to go meet your favorite teachers, register. The link will be there in the description box. So register, because very limited seats are available. Okay, and you can also meet top 100, the JEE aspirants, and you can ask your questions. You get lots of gifts. It's going to be a very, very fun event. Okay, so make sure you all register. Go to the description box, click the link and register. The event is going to happen on Sunday, March 30th. It's going to be from 11 a.m. I'm sure it's going to be so much fun. So make sure you don't miss the chance. Okay, now let's move on to our questions. Yes. Pratnya, it remains stationary. Let's see if it will remain stationary. So the question asks you about a magnetic field and a stationary electron. So the formula that we know relating magnetism and electricity is F is equal to QB cross B. Now, if it's not moving, V is obviously 0. So Q dot 0 cross B is also going to be 0. So what will happen? Q and B are not going to be 0, but since V is 0, it would remain stationary. Okay? So, yes, that's the answer. Is this clear? Can we all move on to the next question? Let's move on to the next question. So, two parallel wires in free space are 10 centimeter apart and each carries a current of 10 amps. Okay, so there are two parallel wires. Both these wires are in the same direction. Okay, and the distance between them is 10 centimeters. The current in both the wires are 10 amps each. Okay, both the wires have two currents. They have the same current, it's 10 amps each, and they are 10 centimeters apart. They're in free space, so there's nothing else affecting it. You have to find out the force exerted by one wire on the other. Okay, it's quite simple if you know the formula. Very important to know the formula. So the force per unit length for parallel wires is mu naught I1 I2 by 2 pi r. Okay, so if you have two parallel wires, the force of one wire on the other is given by mu naught I1 I2 divided by 2 pi r. I1 and I2 are the currents of both the wires. F and L, F is the force, L is the length of the wire. Now you just have to substitute the formulas. What is mu naught? Mu naught is a constant. It has the value 4 pi into 10 raised to minus 7, which you should know. Into, how much is I1 and I2? Both are 10, so 10 into 10. The whole divided by 2 into pi into, what is your radius? It's 10 centimeters, so 10 centimeters would be 10 into 10 raised to minus 2, 10 by 100. So 10 into 10 raised to minus 2. So you would be getting 2 into 10 raised to, how much would you get? So pi cancels, minus 7 plus 2 plus 10 and 10 cancels. This minus 2 goes up, it becomes plus 2 plus 1. So 2 into 10 raised to minus 4. 10 raised to minus 12. And would it be attractive or repulsive? So this is also one thing you need to know. If you have two parallel wires and the force between these wires, the electricity between these two wires, if they're in the same direction, they will always attract. If the electricity is in the opposite direction, which means if you have two wires and this is going down and this is going up, they always repel. So this is definitely going to be attractive, because the electric currents are in the same direction. If the electric currents were in opposite directions, it would have been repulsive. Yes, Vijay, I am new physics teacher. If you're enjoying the class, please give me a like and let me know in the comments so I can improvise on how classes should be. Yes, Vaishali, it's option A. Very good. Okay. 2 into 10 raised to minus 4. Now let's move on to the next question. I think I should move a little more fast because we have lots of questions and we don't have the time. So you have to, which of these field patterns is valid for an electric field and a magnetic field? So if it has to be valid for electric field and magnetic field. So if let's look at option A. Option A is basically field lines coming out. This is basically for positively electric charge. Electric charges have field lines. Positive electric charges have field lines coming out. This is not there for magnetic field. Cancelled. Now this is electric fields coming in, which is for negative electric charges, which is also not valid for magnetic fields. Now this is for a straight current carrying wire. It will have a magnetic field around it. but I don't think it's there for electric field. So let's go to the last option, which is the option. So this is something that is valid for both electric and magnetic field, because option D is possible for magnetic field lines of a solenoid. If you see, it looks like this. And if you look at electric field lines of a dipole, it also looks the same. Dipole is when you have positive and negative, the field lines will look the same. So the option is option D. Yes, very good. Pragna, Aishu, Vaishali. Yes, it's option D. Very good. Let's move on to the next question. So, think that your doubt, I'm not able to see the whole thing. I will answer to it when I'm able to see it properly. Yeah, so if this question is clear, can you all give me some fire emojis? Quick, quick, quick. Let's just keep the chat running. So you also have an energy and I also have an energy. Only if I see something there, I get the energy. Because I sit in a room alone with just a screen. Okay, you have to understand how depressing that is. It's different to teach in a class with students and to teach onto a screen. Okay, let's move on to the next question. Magnetic field due to a current element. Okay, so the magnetic field at the origin due to a current element, the current element is IDL. It's placed at a point with a position R. You just have to find out the field. So Digant, I believe, I'm sorry if I pronounced your name wrong. So if current is flowing in the same direction, electrons also flow in the same direction. Then why is it not repulsive? It actually does not work like that. If you use your rule, okay, where the direction of force, direction of magnetic field, and direction of current, you will see that if the direction of current is upwards, the direction of magnetic field is with your fingers. So direction force will also be in this direction. Okay, so force is going to be like this. Now on the other side, again, you have current moving up. So magnetic field is like this. So force is this way. So in the first case, force is this way. For the other wire, force is this way. Since both the forces come together, they attract. Okay, so this was a question asked by one of the students. It was by Digant, so that's why I've explained it. This is from the previous question. Okay, yeah, let's move on. It's basically forces that make it attractive. The direction of forces are inwards. Yes, for question 13, the answer is mu 0 I 4 pi dl cross r r cube. Option A. Yes, this is a direct question. You might have already understood. So the only difference is the current element is IDL. So make sure your answer will have that. Great. Okay, let's move on to the next question. So you have to find out how the current varies. Okay. Sorry, the magnetic field, which is on the x-axis, the y-axis, the magnetic field varies. So there is a long cylindrical wire. Hi Pranav, why are you late? You should have joined earlier, no? We did so many exciting questions. You can go watch the recording. Okay, so yes, so I have a current carrying wire. It's a cylindrical wire. This wire has a radius of r. Okay, and this wire has a uniform current of I flowing through it. We have to find out how magnetic field varies inside the wire. So inside the wire, I take another small element which has a radius small r. Okay, so there's a small element small r and there's a big element r. So we will find out how magnetic field varies here. So let's do that. So first thing, so if I have to explain from the starting formula, it will take some time. So what should I do? Should I? So, okay, let's do it that way only. So this is the magnetic field of a cylinder. Okay. No, I'm just putting it as a cylinder because it's a wire. Okay. Now the total, this A total, A is pi r square. Okay. Now the current density passing through this is I by A, which is I divided by pi r square. Now inside this I have an enclosed section. So I have an enclosed section. So here this one's area is pi small r square. So this one's current, which is I enclosed, will be J into A enclosed. Okay. Now, what is J? I divided by pi r square, and then this is A enclosed. So I enclosed is basically A enclosed is again pi r square. I divided by pi r square into pi r square. So pi cancels. This is I r square by r square. This is what we are going to use here. Okay. So magnetic field inside the whole conductor is going to be, we know for a straight wire it is 2 pi IR by r square. This IR by r square is from here. Okay, so these two cancel. So B in is mu 0 by 2 pi I r by r square, where I is the current. Now, everything else is a constant. The only thing that's changing is the radius. So, as I mentioned, if you want to make a proportionality, you take all of this to be a constant. So, I will get B in proportional to R. Now, what would B out be? B out is just the magnetic field on a straight current carrying wire. It's going to be mu 0 I divided by 2 pi R. In the earlier case, it's the magnetic field inside. So I took my I r square by r square, which I derived on the other side. So that you have to learn, okay, magnetic field enclosed inside something will be I r square by r square. So mu naught I divided by 2 pi r. Now again, I take everything that is not changing to be a constant. So B out would be proportional to 1 by r. Okay, so I have direct proportionality and inverse proportionality. So B in is when, so if you look at the graph, one side of the graph is directly proportional, so it should be increasing. So when something is inversely proportional, it should be decreasing. So the answer would be option, which one would it be? Quickly, someone tell me. It would be option C. Okay, it would be option C, because at this part, B would be proportional to R, and here B would be proportional to 1 by R. So when it's directly proportional, it increases, inversely proportional, it decreases. So here you can see R is less than R, which means it's inside the wire. Here this is R is greater than R. No. Other way around. Here, in both the cases, R is less than R, but it's inside the wire. Here it is the full wire. Okay. Yes, it's option C. If you have all understood this, can you again put some fire emojis in the chat? Next question is the ratio of magnetic field to magnetic moment. Okay, this is also a very interesting question. It's a very easy question as well. If you listen carefully, I mean, if you read and pay attention, it's a very easy question. It's a very interesting question also. So let's do this together. Come on, everybody. All those who are sleeping, please wake up. So magnetic field B is how much? For a straight current carrying wire is mu 0 I by 2R. You might have learned this formula by now. We've done so many questions based on this. Magnetic moment is IA. What is A? A is pi r square. Okay. Now in the question it says the ratio of magnetic field to magnetic moment is X. Okay. So that means by M, the ratio of magnetic field to magnetic moment is X. It's given to you. Now we know what is B, we know what is M. Let's substitute. Mu naught by M divided by 2R, the whole divided by, how much is M? I pi R square. This much is going to be X. So now quickly doing all the math and solving it, you will get mu naught divided by 2 pi r cube is equal to X. Okay. But that's not the end. You have only found out X. So this is the ratio of magnetic field and magnetic moment. But now look at the rest of the question. If the current and the radius both are doubled, how will this ratio change? So this is the initial ratio. How will this ratio change? Let's look at that. So B dash minus M dash will be how much? Mu 0, instead of I, it would become 2I. Instead of R, it would become 2 into 2R. The whole divided by. Magnetic moment is how much? Pi R square. Instead of I, it becomes 2I. So 2I pi. Radius has also doubled. So it would, instead of R square, it would be 2R square. Let's do the math. So this is going to be mu 0 by 16 pi r cube, which is basically 1 by 8 into mu 0 divided by 2 pi r cube. What was mu 0 by 2 pi r cube? Our previous ratio x. So this is going to be 1 by 8 x, which is x by 8. Let's see which option that is. X by 8. Option D. Did you all get option D? So what we've done is very simple. What did we do? We found out the formula for magnetic field. We found out the formula for magnetic moment. You found out the ratio between them. The ratio is given to be X. And then the magnetic field and magnetic moment will change because the radius and current doubles. So you take the ratio of the doubled quantities and then you compare it with the first X ratio. Okay. Okay, let's move on to the next question. So the effect of increasing turns in a galvanometer. So if the number of turns in a galvanometer is tripled, then what happens is the question. So let's look at the basic formulas for that first. So we will look at current sensitivity and voltage sensitivity. So current sensitivity is how much? SI, I will write it as current sensitivity, is basically by how much my theta, the galvanometer needle, deflect for a small amount of current. So this is also equal to the number of turns times magnetic field times A divided by K. So quickly, if SI becomes 3, the number of turns is tripled. So N would be 3, 3BA by K. This would basically be Xi dash. So this would basically be 3 times SI. So current sensitivity increases 3 times. So that's the only option that has current sensitivity. The answer is option B. But I will show you how to do voltage also. So voltage sensitivity is SV. Ohm's law, it's basically theta by V and then current by resistance. So if current increases 3 times, resistance will also increase 3 times because the same wire is going to go 3 times. So SV would be 3SI by 3R, which is SI by R, which is SV itself, SV dash. So voltage remains constant. Okay. So see, how did R become 3R? Because if current increases, resistance also increases. See, the same coil is taken 3 times. So the resistance will also be increasing by 3 times. Okay. Yes. Let's move on to the next question. So this is to find out the magnetic field at the center O in the given figure. So the magnetic field is taken like this. Let's do this. So the magnetic field for the whole loop, okay? The magnetic field for the whole current carrying loop, carrying a current, is what we have to. There's a small 60-degree segment also here. So the total magnetic field at O will be the magnetic full circle minus the magnetic field at the 60-degree angle. Okay. So let's find out the magnetic field of the full circle. So B full is going to be how much? Mu 0 I by 2R, the formula that we have been using. Now the missing part, B missing, would be equal to 60 degrees divided by 360 degrees into B full. So this is going to be 1 by 6 times mu 0 I the whole divided by 2R, which is going to be mu 0 I divided by 12R. Now the full field due to O would be V full minus B missing, which is going to be mu 0 I by 2R minus mu 0 I by 12R. Now when you do the math, you will get 5 mu 0 I divided by 12R. Okay. So this is going to be the answer. 5 by 12. It's going to be option B. So the missing part is 60 degrees out of the 360 degrees. That's why 60 by 360 into the full scale. So if you've all understood, can you all give me some fire emojis? Okay. Okay, Lord Satar. After the video you watch in 2x. Okay. So now next is Biot-Savart's law in vector form. This is a very easy question. You should all get it. What is it? dB is equal to mu 0 by 4 pi IDL cross R cap by R cube. Okay. Now if this I can write it as R cap is R by R. So this can also be written as mu 0 by 4 pi IDL cross 1 R and R I take. So it would be R cap by R square. Yes. Yes, Naresh, Aishu, Dhruti, thank you all for being there till now. So next question is question 19. Let's move on to the next question. A charge Q is accelerated through a potential difference V. It then enters normally into a uniform magnetic field moving in a circular path of radius R. What potential difference is required to move the charge in a circular radius? Let's do it. As I said, every time you see circular path or radius or anything, the first formula that should come to your mind is mv square by r. Now let's understand the question first. So a charge is moving in a uniform magnetic field. Okay, the magnetic force provides a centripetal force. That's why it's moving in a circular path. So QVB, it's a charge and a magnetic field. So QVB is definitely there. It's going to be mv square by r. So r is going to be mv divided by QB. Okay. Now what will I do? What else should I do? R is mv by QB. That's fine. Now I can substitute. Okay, one thing that I can do here is I need to find velocity. So what is one formula that you know for velocity? The only formula I can think of is kinetic energy. So let me write that. Kinetic energy is half mv square. Now this kinetic energy is for the charge to move in a potential. So this kinetic energy should be charge times potential, half mv square. So from this, let me find v square. V square is how much? Square root of 2qv by m. So I can remove this v square part. So v is equal to 2qv by m. SP Gaming High. Okay. So v is equal to square root of 2qv m by m. I substitute that for r. So r is equal to m into square root of 2qv 2qv by m. I got that divided by qb. Now if I have a square root, no, I will write the number first. So m is basically what? Square root m into square root m. So if I have m by square root m, what is it going to be? Square root m into square root m divided by square root m. So many square roots. So what is it going to be? Square root m. Okay. So this principle I will apply here. I want you to think and apply. So r would be equal to what? I have an m divided by square root m. So it becomes square root m. So square root m into v2 is already there. Divided by, I have a square root q by q. That would become square root q. And then b would be here. No CSK fans here. Only physics fans. Free Fire King. You're a CSK fan. Okay. So square root 2m v b root q, that much is done. Now what will we do? What else is given to the question in the question? What potential difference is required to move the charge in a circle of radius 2r? So you have to find out the potential when the radius becomes 2r. So let's make the radius 2r. How do you make the radius 2r? You multiply it with 2. So 2r would be square root of 2m. V would become V dash because it's a different potential. B times square root of Q. Now I will take the ratio between the two. So let's divide 2r and r. What will I get? BQ I cancel. It's there in both. So let's not write that. So this would be square root of 2mv dash divided by square root of 2mv. Is basically square root of v dash by v. Oh, I'm writing behind my head. Are you not able to see? I will shift the board. So square root of v by v. So 2 is equal to, r and r would cancel, square root of v dash by v. 4 is equal to v dash by v. 4v is equal to v dash. So the answer is 4 volt, which is option B. Okay, so this question is clear. Let's move on to the next one. I will finish the class quickly, okay? I think all of you will watch this in 2x if you want to. Yes. I'm doing all the steps because, I don't want anybody to miss out on anything. You don't get KCET materials a lot on the internet. Even I took a lot of time to get all these questions. So if it's helpful to anyone, I'm happy. So next question is question 20. So simple question. We've done a similar one. F is Q, V cross B. How do you find V cross B? You put I, J, K. So F is basically 10 raised to minus 6 because the charge is 1 microcoulomb. So 10 raised to minus 6 into the 10 raised to minus 3 from B. I take it outside. And then I, J, K is 2, 3, 4, 5, 3, minus 6. I've already explained on how to do this. So you will basically get minus 30 I cap plus 32 J cap minus 9 K cap into 10 raised to minus 9. Yeah, minus 9. So this much is which option? Oh, I didn't put options for this question. Okay, I'm sorry for that, okay? So the answer would be this one. Minus 30 I cap plus 32 J cap minus 9 K cap into 10 raised to minus 9 newtons. I don't know how I missed the options, but yeah, that's the answer. Okay, let's look at the next question. Next question. I don't know if I have the time for that, but yeah, let's just quickly do it. Okay, so current I is flowing along an infinite straight wire with a positive Z and negative. And the same current is flowing along a similar wire 5 meters apart. So there are two wires. Okay, let's say the wires are 4 coming to you. It's like this. So these two wires are 5 meters apart. I have to find out the magnetic field at a point P. Okay, so the magnetic field has to be found at a point P, and this point is 3 meters from one side and 4 meters from the other. So let's say this is A and B. So P is 3 meters from one and 4 meters from the other. The wires are going this way. So how will I do that? First, I will find out the magnetic field on A. So B on A would be mu 0 by 2 pi. How much is it? I divided by 3 because it's at a distance 3. And B of B would be mu 0 by 2 pi I divided by 4 because it's at a distance 4. Now, how do I find out the magnetic field at point P? See, this is similar to a right angle triangle. One is 3, one is 4, one is 5. Okay. So, what I will do is the magnetic fields will also be similar. So, the magnetic field at the hypotenuse will be, so it's because of my drawing, ideally 5 should be the hypotenuse. This is not the figure. So, when you draw it, you should draw it such that 5 becomes a hypotenuse. So B is basically a root of BA square plus BB square. And how much would that be? B would be mu 0 by 2 pi outside square root of I will put it outside. 1 by 3 square is 1 by 9. 1 by 4 square is 1 by 14. Sorry, 1 by 16. So this is going to be 5 by 24 mu 0 I by 5. Where is that option? 5 by, yes. So this is going to be the answer. Okay. Next question. Parallel current carrying wires. Okay. So you have two wires and they are placed at a distance D. A is the center. So that means both the sides would be D by 2. If A is the center, both the sides would be D by 2. You have to find out the resultant at the central point A. Okay. So let's do that. Magnetic field B is equal to mu 0 I divided by 2 pi into D by 2. And then magnetic field because of B2 will also be mu 0 I divided by 2 pi times D by 2. And then you basically multiply them. Sorry, add them. Yeah. Okay. So it becomes mu 0 I. This is I1. This is I2. 2 pi D by 2. So all of 2 goes out. Let's just add them. B is B1 plus B2 because you have to find out the magnetic field because of both at the center. So why, when I am adding, why am I getting the central point? Because that's how I've taken the distance. It's D by 2 on both the sides. So when I add those two fields, I should get the field at the center. So this becomes mu 0 I1 times pi D plus mu 0 I2 times pi D, which is mu 0 by pi D I1 plus I2. Okay, so if you can't see it, I will just show it to you. Okay, so which option is that? Mu 0 by pi D I1 plus I2, option D. Yes. Okay. Next question is a direct question, which I think you can definitely solve by yourself. So, circular radius 10 centimeter, 100 turns, current is 1 amps. So, the formula is B is equal to mu naught. Why do the pens? Mu naught Ni divided by to R. So R is given to you. R is 10 centimeters. You have to convert that into meters. Okay, I will write that also. So 4 pi U naught is 4 pi. So 4 pi into 10 raised to minus 7 into 100 into 1 divided by 2 into 0.1. Your answer would be 6.28 into 10 raised to minus 4. Okay? Let's move on to the next question. So it's already 9:30. So in a single minute, I will quickly discuss some theory questions as well, because I had people ask me for theory questions. So first question, the magnetic field lines inside a solenoid are always parallel. The field lines form uniform. They're always parallel and uniform. Okay. Next question, the force experienced by a moving charge in a magnetic field is maximum when the formula is F is equal to QVB sine theta. So when would it be maximum? When it is F is equal to QVB. So theta should be 1 or 90 degree. Okay. So what would the option be? It would be option B. It should be perpendicular. It should be 90. Yeah, 26. Which one? It's Gauss law in electrostatics. Gauss law and Ampere circuit law is similar. What is Ampere circuit law? It says that integral B dot dl is equal to, it's similar to the Gauss law in electrostatics. You can look at both the laws. They look similar. And then question number 27 is galvanometer can be connected to an ammeter. How? Yes, this is a very simple question. And then the next question is the direction of force on a current carrying. Obviously, the Fleming's left hand rule. So the Fleming's left hand rule says this. Thumb will give you the force. This is going to give you magnetic field and then the direction of current. Okay, so I think that's the end of this chapter. So I've taken questions from all past year papers. All these questions were from 2018 to 2024. All the questions we have covered. So I think all of you were able to do it. And it was a little long and a little slow because I wanted everybody to understand. So you can all definitely watch it on 2x. And if you're watching it on 2x and you've watched till here, thank you so much. Please give me a like, okay? And let me know in the comments if you've liked the video so I can come up with more. It actually motivates me if you give me good comments. So thank you so much for watching. Bye-bye. I'll